There's no special effect of lighted fluid or something.
Hey baby, I like the look of your electron.
Get lost, Clyde.
Oh baby, seems to me you ain't as stable as you might be if you had given me your electron. You sure you don't want to reconsider?
I would never share my electron with you.
Baby, I ain't asking that much from you. That's too much commitment. Besides, my electronegativity is a 3.0. Come on, girl.
If I gave my electron to you, I'd be electrostatically attracted to you forever. I don't know if I can handle that.
Baby, it's okay. We'll work it out. Besides, we'd be the perfect salt together.
I don't know if that's the way this is supposed to be.
Baby, of course it's the way it's supposed to be. You complete my valence shell. Besides, we're even in the same periodic row.
Wow, really? Okay.
Thank you.
No!
Done.
So, the rule is that electrons fill shells subsequently.
Yeah, but then in row 4, you fill the 4 s orbitals before the 3d orbitals because electrons in the s orbitals are more penetrating.
And that pattern of filling the s orbitals before the d orbitals continues on after that.
Yep.
But what about copper and chromium? Why are their electron configurations different?
You mean how there's only one electron in the 4s shell and then like 5 or 10 in the 3d?
Yeah, I thought that the 4s shell got filled before the 3d.
Well, copper and chromium are exceptions to the rule. In copper, both outer shells are half full, so that might have something to do with why copper prefers this configuration. And with chromium, having a full level where 10 electrons hang out and having one where just 2 hang out is also more preferable.
Strange. So what about the frequency factor rule?
Well, you'll never be tested on it pretty much, either in class or on the AP test. So it isn't really worth memorizing. Just remember what it means and if you were to use it.
Oh, I see. I can do that.
So when I was at the University of Rochester, the best and easiest place to get ice for a party was in the chemistry department. And because the building was usually open late, you could get up inside to where the hallways were, where the big ice machines were. So one day we were going over at about 10 o'clock at night to get big buckets of ice for the party. And as we were coming out, one of the teaching assistants was coming up the stairway. He said, "What are you doing with all that ice?" And we said, "Well, we're studying the cooling curves of ethanol." He thought it was hysterical and let us go and get the ice. So